Let us continue the lecture on differential equations. Now we shall take up problems for where RHS is 0. That is, for example, solve d squared minus 5d plus 6 operated on y is equal to 0. Or this can be written as d squared means d squared by dx squared. Power of d is 2. Therefore, y is differentiated 2 times d squared by dx squared minus 5 written as it is. D means power of d is 1, therefore dy by dx plus 6 into y, 6y is equal to 0. So when either the problem can be given in this form, or can be given in this form. Suppose if it is given in this form, how do you write? 2 times different y, it is differentiated 2 times differentiation, therefore power of d must be equal to 2. Y is differentiated 2 times, power of d is equal to 2. Minus 5, write that as it is. Dy by dx, y is differentiated one and only once, so therefore power of d must be 1. What is number behind y? 6. That is what I have written. Now, how to solve this differential equation? What is the formula? General solution is equal to complementary function only. Why? Because the RHS is 0. I told you several times, when the RHS is 0, general solution is complementary function only. If this RHS is not equal to 0, then general solution is equal to complementary function plus particular integral yp. But what is happening? RHS is 0, therefore general solution is equal to complementary function. To find the complementary function, what I have to do? I have to first find the roots of the equation. What is the equation? D square minus 5d plus 6 is equal to 0. Find out the roots. Use d is equal to minus b plus or minus square root of b square minus 4ac by 2a. What is a? Number behind d square. A is equal to 1. B means number behind d, that is minus 5. C means this constant 6. Then you will get 2 roots. Substitute in this formula. D is equal to minus b plus or minus square root of b square minus 4ac by 2a. You will get 2 roots. D is equal to 2 and 3. So what I did? Number behind d squared, that is a. A is equal to 1. Number behind d, that is b. B is equal to minus 5. This number c. This number is c. C is equal to 0. Substitute. You are getting 2 roots. D is equal to 2 and 3. How are these roots? These roots are different. So therefore, this is coming under case 1. What is case 1? C1 into e to the power m1x plus c2 into e to the power m2x. See the table, first case. See the table, first case. Complementary function is equal to c1 into e to the power this 2, this 2x plus c2 into e to the power this 3, whatever is here, this 3x. So that is the complementary function. Now, so this itself we call this as general solution. Now, example 2, let us take this example. Find the complementary function for the problem d plus 1 whole cubed into d minus 5 is equal to 0. Either he may ask find the general solution, or he may ask find the complementary function, or he may ask find the particular integral, etc. In many number of ways he can ask. Find the complementary function to the problem d plus 1 whole cubed into d minus 5 is equal to 0. D plus 1 whole cubed, that means what? D plus 1 is equal to 0. Take this d plus 1, it is equal to 0. So d is equal to minus 1. See, observe what I am doing. Take d plus 1 whole cube, that is d plus 1 is equal to 0. So therefore send it to this side, d is equal to minus 1. Whole cubed is there, so therefore this minus 1 is repeated 3 times, right? D is equal to minus 1, minus 1, minus 1. Now take this factor, d minus 5 is equal to 0, d minus 5 is equal to 0, so therefore d is equal to 5. So therefore you got 4 roots. What are the roots? Minus 1, minus 1, minus 1, and for this 5. Now how do you write the complementary function? Complementary function. These 3 roots are repeated. So therefore, clearly observe how I am writing the complementary function. Complementary function, it is equal to, right, roots are repeated. Case 2, observe clearly, roots are repeated. In that, complementary function is equal to c1 into c1, right, for this first root, plus for the second root, think like this, c2x. For the third root, this is minus 1. For the third root, c3 x square. I repeat, observe, for the first root, c1. For the second root, c2x. For the third root, c3x square into e to the power minus 1 into x plus. Now this root is different. c1, c2, c3 are over. Therefore, c4 into e to the power 5x. So this is how I am writing the complementary function for this problem. Refer to the table. What is it in table? It is coming under case 2. This one comes under case 1 in the table. Now let us go to next problem. What is the next problem? Solve the differential equation d minus 3 whole square into d minus 2 whole cubed operated on y is equal to 0, or he may ask find the general solution. Now, as you know, I have already told you general solution is equal to complementary function plus particular integral, but RHS is 0. When RHS is 0, what is the general solution? Complementary function only. Now, d minus 3 whole squared is equal to 0. If you take d minus 3 whole squared is equal to 0, d minus 3 into d minus 3 is equal to 0. d minus 3 is equal to 0 gives you d is equal to 3. So, whole squared is there. Therefore, 3 repeats 2 times. Now, d minus 2 whole cubed is equal to 0. So, d is equal to 2. 2 repeats 2 times. So, what are the roots? 3, 3, 2, 2, 2. Now, let us write the complementary function. Now, let us take this set 3, 3. When the roots are repeated, how we are writing? When the roots are repeated, observe the point. When the roots are repeated, how we are writing? For the first roots, for the first one, C1. For the second one, C2x. Observe. For the second one, C2x. Isn't it? For the first one, C1. For this, C2x into e to the power 3x. Now, let us take this one. These roots are different. So, therefore, plus. C1, C2 are over. Now here also roots are repeated. Observe. Here also roots are repeated. For this C3. Next for this C4x. For this C5 x square. Right? Into e to the power 2x. You have to write e to the power 2x. Into, here I am writing e to the power 2x. Right? So this is the complementary function for this problem. Now suppose, let us take another problem. D squared y by dx squared plus 4y is equal to 0. Find the general solution. Now what is the number behind y? Sorry, y is differentiated 2 times. So therefore power of d must be 2. I have written. Y is differentiated to the power of d must be 2. Number behind y is 4. So I have written that. D squared plus 4 is equal to 0. So d squared is equal to, right? Observe. D squared plus 4 is equal to 0. So therefore d squared is equal to, here y is differentiated 2 times. So power of d must be 2. What is number behind y? 4. D squared plus 4 is equal to 0. Now d squared, this d squared is equal to minus 4. Bring it to this side. So d is equal to plus or minus square root of minus 4. So d is equal to, this it can be written as 0 plus or minus. This root of minus 4 is root minus 1 into root minus 4. Root of AB, you can write that as root A into root b. Similarly, root of minus 4, it is written as root of minus 1 into root of 4. So d is equal to this 0, written as it is, plus or minus. For root of minus 1, what is the value of root of minus 1? Observe, root of minus 1 value is I into root 4 is 2. So d is equal to 0 plus or minus I into 2. I repeat, square root of minus 4. This can be written as root of minus 1 into root of 4. Root of minus 1 into root of 4. For root of minus 1, I. Observe. For root of minus 1, I. You are substituting. For root of 4, 2. So therefore, you have d is equal to 0 plus or minus I into 2. So alpha is equal to 0, beta is equal to 2. Substituting this formula, what is the, when this is coming under case 3, isn't it? Complex roots, e to the power. What is alpha? 0, e to the power 0x into C1 cos beta. What is the value of beta? Beta is this number behind I, that is 2 cos 2x plus C2 into sine number behind I, 2, that is, this is the complementary function. Now let us go to one more example. D squared y by dx squared minus 5 into dy by dx plus 6y into d squared y by dx squared plus 16y is equal to 0. Now y is differentiated 2 times. Power of d must be 2. Power of d is 2. Y minus 5, write that as it is. Dy by dx, one and only once differentiated. So power of d must be 1. Number behind y, 6. I have written as it is. Now coming to this here. 2 times differentiation, power of d is 2. Number behind y, 16. So this multiplication is equal to 0. So from this, if you find the roots, apply the quadratic formula. D is equal to minus p plus r minus square root of b square minus 4ac. If you apply the formula, you are getting the 2 roots from this. From this, you are getting 2 roots. D is equal to 2, D is equal to 3. Or otherwise, operate the calculator, you will get 2 roots. D is equal to 2, D is equal to 3. From this, d squared plus 16 is equal to 0. D squared is equal to, Here also you can operate the calculator. D square plus 16 is equal to 0. D square is equal to plus 16, bring it to this side, minus 16. So D is equal to plus or minus square root of minus 16. So D is equal to 0. This can be written as 0 plus or minus, right? Root of minus 1, carefully observe, into root of 16. So therefore D is equal to 0. I have written that as it is. Root of minus 1. For what is root of minus 1? I. Observe. Square root of minus 1 is I. Square root of 16 is 4. So D is equal to 0 plus or minus I into 4. So what is this? This is alpha. What is this? Beta is equal to 4. So what is the complementary function? E to the power alpha x into C1 cos beta x e to the power alpha x into, these are complex. Observe, root of minus 1 I. Here root of minus 16, it is written as root of minus 1 into root of 16. Root of minus 1 is I. Root of 16 is 4. So complex roots. Case 3. This is coming under case 3. So therefore e to the power alpha x into C1 cos beta x plus C2 sin beta x. So e to the power, what is alpha? Alpha is 0. E to the power 0x into C1 cos beta. What is the value of beta? Beta is 4. Here observe, beta is 4. C1 cos 4x plus C2 into sin beta. What is beta? Beta is 4 sin 4x. Right? So this is the solution problem. Now let us take a last problem on this. D square plus 4 whole square operated on y is equal to 0. This is a special case when complex roots are repeated. I have not given it in the table. What is the formula? When complex roots are repeated, that is, this case is like this: alpha plus or minus I beta, again alpha plus or minus I beta. Alpha plus or minus I beta complex root. Again if it is repeated, then the formula is this one. Then the formula is e to the power alpha x, c1, c2 x, cos beta x plus c3, c4 x, sin beta x. For example, if I take this, d squared plus 4 whole square operated on y is equal to 0. So how do you write? D square plus 4 into d square plus 4 is equal to 0. Just I have told you, take this d square plus 4 is equal to 0. What are the roots? D squared is equal to minus 1, d squared is equal to minus 4, d is equal to 0 plus or minus square root of minus 4. D is equal to 0 plus or minus square root of minus 1, I. For this minus 1, I. Square root of 4, 2. So what is that? Alpha is equal to 0, beta is 2. So again you take this one. I have taken d square plus 4 is equal to 0. Again you take this d square plus 4, same thing. You will get alpha is equal to 0 plus or minus 2i. So this 0 plus or minus 2i here, again 0 plus or minus 2i, it is repeated case. Observe. For this d square plus 4, you are getting 0 plus or minus I into 2. For this d square plus 4, again you are getting 0 plus or minus 2i. That is, complex roots are repeated. Then in that case, you are using the formula e to the power alpha x c1 plus c2x into cos beta x plus c3 plus c4x into sin beta x. What is the value of alpha? Alpha is 0. Just substitute. Alpha is equal to 0. So therefore complementary function is equal to e to the power. What is alpha? Alpha is 0. E to the power 0x into c1 plus c2x into cos beta. What is the value of beta? Beta is 2x plus c3 plus c4x into sin beta. Sin beta is 2x. So this is what we are getting